Hello, everybody. Today we've got another visual pattern challenge, and boy, is this one difficult. If you've been getting the hang of these linear patterns and maybe even got that one quadratic pattern that we've done so far, this one may stump you. So it's definitely a high level of challenge. But let's start looking at it and go through the process. Even if we can't really get it all the way, we can at least do something, right? We can figure out what's in the next step for sure. Maybe step 43 is a little much to ask, but we'll see what happens. So as I look at this pattern, first of all, you want to figure out what's actually the pattern is, and I'm deciding that these triangles are triangles, the ones facing upwards, and this one inside, that's an empty space. So I'm seeing that as empty space. All those downward pointing triangles that get formed are empty spaces. So in step 1, step 2, step 3, we're seeing one triangle, and then 1, 2, 3, and then 1, 2, 3, 4, 5, 6 triangles. So let's make a chart for that because we really do want to be thinking about this carefully. So there's the step number, and then there's the number of triangles. So in step 1, we've got one triangle. In step 2, we've got 3. And in step 3, we've got 6 triangles. And before we start taking a difference, let's actually see if we can predict step 4 here, because I think we can do that. What I'm noticing is here's my one triangle, and here's my one triangle again in step 2. And what I've done is I've added another row with one more. So there's a row of 1 and a row of 2. And here I've got the row of 1, the row of 2, and then I've got the next row of 3. So what I'm thinking is that the very next step is going to have 4 triangles. That seems to follow the pattern to me. 4 triangles more. So added 4 on the bottom. So we've got 4 and 3 is 7, 8, 9, 10. So this would be 10. So we've at least gotten here. We've gotten to how many in the next step. There are 10 triangles in the next step. To write an equation to get step 43, we really have to do some analysis about what's going on. So the first thing to do is to look at the difference. So 3 minus 1 is 2, the difference between each step. 6 minus 3 is 3, so they're not the same. And 10 minus 6 is 4. So it's not a linear pattern because the change is not constant. Let's take the next set of differences though. So 3 minus 2 is 1, 4 minus 3 is 1. Aha. So when you take the difference of the differences, it means that this is quadratic. So that there's going to be an x squared somewhere in this thing. I don't think that's all that's going on, but an x squared is going to be part of it somehow. So let's just start fooling around with the numbers that we have and seeing how x squared can fit in. If we just took x squared, it would work for step 1, right? Because x squared, 1 squared, if we're putting in the 1 for the x, that's the step number for x. So if y equals x squared, we got y equals 1, that's the number of triangles. So that works. But the minute we move on to the next step, it doesn't work. So 2 squared is 4, and we have 3 here. 3 squared is 9, and we only have 6 here. And what I'm noticing is in these next 2 steps, the number of triangles we end up with is less than the squared step number. So to get something to be less than, I have 2 strategies. I can subtract something, or I can divide it. Maybe I can do both, I don't know. If we subtract something, we'd have to subtract the same thing. So our equation would be x squared minus some number. So let's try to make that work with step number 2. Here we have 3 triangles, so 2 squared minus 1 would be 3, so that would work. But here, back at step 1, 1 squared minus 1 would be 0. So that doesn't work. And here, 3 squared minus 1 would be 8, and we've got 6. So subtraction doesn't appear to be working. So to get this to be less than, we've got to divide by something. What I'm noticing also is that they're pretty close to those numbers, right? 3 is not very far from 4, and 6 is not super far from 9. So maybe we divide by a small number and see what's going on with that, and maybe we'll have to add something back. I'm not sure. But let's try with x squared divided by 2. and see what we get. X squared divided by 2, so this would be 1 divided by 2, that'd be 1/2. That's not going to work. This would be 2 squared, so 4 divided by 2, that'd be 2. We're just 1 short. Here we've got 9 divided by 2. Well, that doesn't make sense. We're going to get another half of a triangle there. So it looks like we have to add something back, but we can't add, it looks like we can't add the same thing back, right? Because here we'd have to add 1/2. Here we'd have to add 1. And we got 9/2 for an answer on this one. So that's 4.5. So we'd have to add 2.5 or 1.5. Well, what if, okay, so let's try this. One number that changes every step is the step number. So what if we added in, plus another x here. Let's see how that works. So if we've got x squared plus x over 2, so x squared plus x over 2, that would be 1 plus 1 divided by 2. So that would be 1. It works for the first one. Let's try the second one. This would be 2 squared plus 2 over 2. That would be 4 plus 2. That's 6 divided by 2. That equals 3. Oh, well, it worked for the first two. Let's cross our fingers here. So this would be 3 squared plus 3 divided by 2. So 9 plus 3 is 12 divided by 2 equals 6. Oh, I think we are onto something. Let's just try it with one more. Our prediction for the fourth one: 4 squared plus 4 divided by 2. That'd be 16 plus 4 would be 20 divided by 2 would equal 10. Aha! So this, I think, is our formula, our equation, and we can write that as y equals, let's say 1/2 times, instead of divided by 2, it's the same thing, x squared plus x. Whew. All right, we got there. It works for all of these steps though, so I'm pretty confident. Let's try step 43. So for step 43, we'd need to plug in that 43 for x. So let me write that out. Y equals 1/2 times 43 squared plus 43. So 43 squared is 1,849. So we've got 1/2 times 1,849 plus 43. And that is 1892. So 1/2 times 1,892. And we'll divide that by 2. So that'd be 946. All right, so it looks like there are 946 triangles in step 43. Does anybody want to draw that out and get down to that last row to show that there are 946 triangles? If you do, send me a snapshot of that. I'd love to see it. Well, how did that go for you? Was that as hard as I thought it was going to be? Or did you see this pattern and come up with an equation pretty easily? Let me know. I would love to hear. Thanks, everybody.